Okay, so number one, a teacher graphed the weights and heights of students in the class. Which of these is the most probable scatter plot the teacher created? So we have to know something about what would happen in terms of weights and heights in a classroom. So let's think of ours. Okay? So first of all, what do you know about everybody's weight in this classroom? Raise your hand, please. What do you know? Okay, well, that's true. So we could estimate our weights. We should all be about over 100 pounds, but they're not actually giving us numbers here. Okay, so tell me something else about the weights. Yes? There's some lower. Okay. Did everybody weigh 50 pounds in here? 60 pounds? 250 pounds? 200 pounds? Okay, well then come on, tell me something more about the weights of everybody in the same classroom.
Yes. We're all pretty close.
You're all pretty close, exactly, because it is an 8th grade classroom. So now tell me something about the height of the people in this classroom.
Yeah, sure.
They vary? A variety of heights. Okay, anybody 3 feet tall in here? Like in 3rd grade? Anybody 6, 7 in here? Come on, tell me something else about the heights of everybody in here in general.
We're all pretty close.
You're all pretty close again. Yes, there'll be a little difference in heights, but just like the weights. So look up here. So let's look at this first graph. In this first graph, what remains the same? What remains the same? The heights are all pretty close here, but look at the weights are quite a bit different. So does that represent this class?
No.
No. We just got done saying the heights and the weights are about the same. Well, look at this graph. What's happening here? Well, look, my weight is getting what?
Heavier this year.
Heavier, I'm getting shorter. So that's not true. What correlation do we call this? What correlation would this be? Ah, very good. So that's one of our vocabulary words for later. Look at this one. What's happening here as my weight gets larger? What's happening to my height? Yeah. Now, this would certainly be a good graph for what situation? Yes, very good, Angelica. This would be different classrooms. 1st grade maybe to whatever. 6th grade, it would depend on what my numbers were. But in one class, we know that all the heights and all the weights are about the same. What do we call this right here in terms of your vocabulary?
No correlation.
No correlation.
No correlation. Well, there is kind of, yeah, but it's also a cluster. Okay? But we know this is our answer right there. Okay, good. Right, number 2. Which scatter plot below would be the best representation for the relationship between a person's height and their shoe size? So the person's height is X, and the person's shoe size is Y. So let's write that here, just so we remember it. This would be height, and this would be size. So now let's talk about this in real life terms. Talk about your guys, okay? What happens when we get taller with our shoe size? They get bigger. So as our height gets taller, or the numbers increase, our shoe size gets bigger, or the numbers increase. So when both the X and Y are both increasing, what correlation is that?
Positive.
Positive from your notes. Which one of these shows a positive correlation? C. A positive correlation is just like positive slope. And by the way, there would be our line of best fit. So if you continue to get taller and your shoe size got bigger, we could predict how big they would be by just extending that line out or writing an equation for it. So in this case, our answer is C. Okay, question number 3. Which is the best description of a scatter plot? So here, if you did your research, like you were asked to do at the beginning of class, looked up all those vocabulary words, you should know what a scatter plot is because it was one of them. So, first of all, we know a scatter plot is a graph. We know that from our work. So which answer isn't possible?
D.
D. It requires a coordinate plane, not a bar graph or a histogram. The histogram is just, it's a bar graph that uses a range of data for the x-axis, a range of data. That's what a histogram is, so it's still a bar graph. Okay, so we know a scatter plot represents information gathered from two different pieces of data. Because on the graph we have an x-axis and a y-axis. So, we have some information. Now let's look at our answers, because there's nothing to really figure out except for to determine which answer matches what the vocabulary is. So A, a graph of ordered pairs that come close to representing a line with a positive slope. What we do know is a graph of ordered pairs. But does it have to be a positive slope? No. We know that. Okay? We know that from work we've already done that in question number 1, there wasn't a positive slope there. Remember, it was just a cluster of points. Now, letter B, a graph of ordered pairs. So again, we know it's a graph. It is ordered pairs. Used to determine if a relationship exists between two variables. Okay, so does the scatter plot do that?
Yes.
Yes, it does. That's what it does. We have an x-axis and a y-axis. We would label them like weights and heights, height and shoe size, how many miles driven and how much gas used. So we're thinking it's B, but let's just double check C. A graph that displays data by using vertical bars of various heights to represent frequencies. Is that going to be a scatter plot? No, that's not ordered pairs. So we know that's not right. We already knew that wasn't right. So obviously it was B. All right, number 4 says a scatter plot shows a correlation between two sets of data. Like in number 1, weight and height of students in the same class. Number 2, height and shoe size. Obviously, as we get older, what happens to our height? We get taller, so what happens to our shoe size? It gets bigger, so that means both of those numbers increase. What kind of correlation is that? Positive. Positive. As the x gets bigger and the y gets bigger, that's going to create a positive slope, or in scatter plot language, a positive correlation. So which statement is true when a scatter plot is said to have a positive correlation? Well, we just have to go. The two sets of data increase together. Is that true?
Yeah.
Yeah, that's what we just said. Easy squeezy. When one data set increases, the other data decreases. What is that called, Jose?
Negative.
We just said positives right here, Jose.
So that's negative.
Very good. When one goes up and the other one goes down, that's negative. Okay, number 5. If two variables are negatively correlated, as one variable increases, the other variable does what? Well, we know from our vocabulary that we have our y-axis and our x-axis. We know from previous learning that a positive slope is up and to the right, where a negative slope is up and to the left. So let's investigate these two. So let's investigate the positive slope right here. Okay? As this x is increasing, it's going to the right. This y is increasing. So we know that a positive slope or positive correlation means both numbers are getting larger. But let's look at this one. So we know this is a negative slope. So we know that as I'm going this direction, my x is increasing over here. But I know that now I'm going down, so that means my y is decreasing. So as one variable increases, the other variable then must decrease for it to be a negative correlation. And then we know that if I have a graph and all the points are just everywhere, like in this situation, and there's no trend or no pattern, this is no correlation. Number 6, the table corresponds to which of the scatter plots? Well, we just talked about how that relationship between the x and the y, whether both of them are going up, or one goes up and one goes down, or there's no correlation, can tell us what the graph looks like. Well, let's look at these numbers. So we see here that this would be our x, and this would be our y. So look at the numbers. What's happening to our x column? We're increasing. So let's look at what's happening to our y column. 40, 36, 35, 33, oh, we're decreasing here. So we just learned on that other problem that when one increases and one decreases, there is a negative correlation. And we even saw what that looked like. So we know it's down to the left, or I say up, it's down and to the right, or up and to the left. So if I were to graph each of these, this is going down and to the right, and right away that's our negative, whereas this is going up and to the right. This doesn't have any correlation. We would actually call these a cluster. And then this has a little bit of down and to the right, but we notice we have these outliers. So that's not a good set of data. So negative correlation right here, and of course we'd have to match those up if we needed to. But we already know that that's the only one that works. Number 7. The following is a table of data and a scatter plot for the data. Which of the following is the value of B? So we are going to go ahead and we're going to take our table here, and we're going to match them up with the points here and see if we can figure out which point we're talking about that would have to be. So let's start with 1, 4. So that's over 1 and up 4. So that point's right there. That one's done. Okay, let's go to the next point. Over 2 and up 3. So over 2, up 3. So they're talking about that point. Okay, next point is 3C. Well, we don't have it, so we're over 3. And the only point on this line is right there. So actually C must be a 1 then. That would be 3, 1. Okay, then we're at A1. Well, we don't know how far we're going over, but we are going up 1. But the only point that goes up 1 is right there. So that must be this set of coordinates. So we need the x. So how far over did we go? 1, 2, 3, and that's up, or that's going over 4 and up 1. So that must make the A4. So finally, we know this is our point right here. That's our target for B. So what are the coordinates? Over 4 and up 2. We need B, which is the x coordinate, which is right there. So x is 4, and if we needed to, D was 2 if we needed that one. Okay? Okay, number 8. So we're given a scatter plot, and on that scatter plot we're comparing income and percent. But what does that mean? The scatter plot shows the percent of car ownership by income. Which statement is not supported by the data? So here's how much money people make, and here's the percent that have cars. So obviously, if we were to look at this correlation, what would it be? Positive. The more money you make, the more likely it is you own a car. All right. Well, as income increases, so the money is getting more, ownership increases. Is that happening?
Yes.
Yes. We want the one that's not supposed to happen. That's key here. Okay, so that's a good one. Okay, B, all people who have $70,000 household income own a car. So here's the people that have $70,000. If everybody owns a car, what's your percent? Huh? 100% if everybody owns a car. Is that at 100%?
No.
No, it's at about what percent?
About
97.
So about 96% of the people with this income, but that's not what they asked. They said all people. So that's not the one that's supported. Not all people own a car that makes 70,000. Now, just to double check, the line of best fit has a positive slope. We know the line of best fit basically has some above, some below, maybe some on the line. Yep, positive slope. And the percent of car owners is higher than 80% in households where income is above 50. So if I took that up, yep, all of these are above 80%, which is right there. All of these are above when you make 50,000 or more. So we did have the right answer. Number 9, a study of adult men was conducted in England that shows the relationship between smoking and lung cancer. So obviously we know there is a relationship there. You smoke, generally you get lung cancer, throat cancer. You've seen those commercials. The x-axis shows the relative amount of smoking, so that's over here. This could be packs of cigarettes, we're not sure. Number of cigarettes, number of times they smoked. Where 100 represents the average for men who smoke. Okay, so they're actually giving us, here's the average number of smoking, whatever that might be. So we have some that are smoking less than the average, some that are smoking more than the average. The y-axis shows the mortality rate, deaths from lung cancer. Okay, and that could be in the thousands, who knows. All right, according to the data in the scatter plot, there is a, strong positive correlation. So first of all, we know that as we go up and to the right, that's a positive correlation. A strong positive correlation would be a steeper line. So for example, if I made a coordinate plane, here might be a weak correlation. It's fairly flat. Stronger ones are going to be above, for example, 1. We know that if I go up and over, up and over, up and over, when we cut the graph in half, that's a 45-degree angle. That means my slope is 1 over 1. So a strong correlation basically is anything above that 1. So if I cut it in half and now I go above that, that's a strong correlation. Anything below that's a weak correlation. So we can see right here that we have a positive correlation. So I know that this negative correlation right here is wrong. I know that this negative correlation here is wrong. So I have two of them. I have a strong positive correlation or a weak positive correlation. Well, if I go ahead and graph this and cut it in half, okay, basically we're looking at this is above the line, and it looks like it's close to being that strong correlation. It's not flat like it would be going like down here. So we're going to call that a strong correlation, partly because we know that smoking does cause lung cancer. We know that because of the real life experiences we've had. So we have to use sometimes the words in the problem to help us determine if it's strong or if it's weak. So we're going to call that a strong positive correlation. So that'll be A. Number 10, Rachel collected data from her classmates on the number of pages they read as a book report due date approached. After that, she displayed the information in a scatter plot. So over here we have the number of pages read over on the y-axis, and then down here we have the number of days read reading those pages. Which of these shows a trend line that describes what the scatter plot? So every one of these coordinate planes is exactly the same scatter plot. We want to see the trend. Well, we know the trend is called the line of best fit. We know from our vocabulary that when we draw our line of best fit, we want to have as many points above the line as below the line, and if we can, we want to have points on the line. Our line must follow the trends, whether it's positive or negative correlation. So basically we would start down here, we would try to cut those points about in half, so it might seem something like that. I got some points below the line, I got some points above the line, about the same, and then I have a few points on the line. So that would be a good line of best fit right there. And what we would do with that line of best fit is we could determine the equation for it, and then we could extrapolate into the future by substituting numbers in for either the x or y to determine the other, whether it's pages read or days. So which one of our answers matches that? Right over here. So B is our answer. Number 11, which line appears to be the best fit for the data points? Okay, this is kind of like number 10, except for it's a little bit closer to each problem being the correct one. But we know that we want to split the points in half with our line. So let's just decide which ones don't do that. Well, this one doesn't. Most of our points are all above the line, so that's wrong. B, here most of our points are below the line, so that's wrong. C, I have some points above, I have some points below, and I have some that are almost on the line. So that's pretty good, so let's check D out. And in D, you again can see that most of the points are above the line, so that's not correct. So C is our line of best fit. Number 12, which of the following graphs shows a line that best fits the data? Same kind of problem, but here's even a little bit closer to being correct. So this looks good. I have 1, 2, 3, 4 above, and 1, 2, 3, 4 below. So that's really good. Here I have 1, 2, 3, 4 above. Okay, actually I have 5 above. And then here I only have 1, 2, 3. So even though this looks okay, it's not quite as good as letter A, so that's wrong. Here on C, you can see that I have some on the line, but a majority of my points are below the line. There's none above, so that we know that's wrong. And then D, all of my points are above, so that's not right. So even though A and B were pretty close, A is a better line, even though B would have been okay. Number 13, which of the following describe the line of best fit for a set of data points? The line should follow the tendency of the data from first to last point. Yes, we know that. We know that's true. 2, there should be about as many points above the line as below the line. Well, I just got done saying that, so 2 is correct. The points at each end are concentrated on one side of the line. No, that doesn't matter whatsoever. And most of the points are above the line. That's actually wrong. We want the same number of points above and below. So my two answers were 1 and 2, which is right there. 14, the scatter plot shown needs its line of best fit to be adjusted. If the line shown has a slope of 7/6, what should the slope be changed in order to get the best fitting line? Well, first, let's determine what we need to do to the line. So I'll use red. So here's what the first line is doing. It looks like that. But we can see that there's too many points below. So I know that I'm going to have to move this down a little bit so that there's just as many points above as below. So I have 1, 2, 3, 4, 5, 6, 7 above. And I have some on the line. So actually this would be maybe over a little bit. So 1, 2, 3, 4, 5, 6, 7. I have 1, 2, 3, 4, 5, 6, 7. So right there. Well, we know from our previous experience with slope that the higher the slope number, the steeper the line. So if I were to take this point going up this direction would make my slope larger. Okay? Going down this way would make my slope smaller. So when we did this right there, the slope originally we know is 7/6. I need to make that number smaller. Okay? Well, we know it's not a negative slope, so that's wrong. Again, we know it's not negative, so that's wrong. So I have these two numbers. Well, which one of these is 1 of these is 10/7. One of these numbers is smaller than 7/6, and one is larger. Okay? Well, this is 1 3/7. And this is 1 1/6. So 1 3/7 is larger than that. That would have made this line go steeper. So we needed it less D, so that was C. 7, 6 is 1 and 1, 6. 1 is less than that, which is the way we wanted to go. Number 15, my tested an experiment in physical science class which resulted in the following data as graphed. With what equation would best represent the data? Well, we know the purpose of a line of best fit is to actually create an equation that we can use mathematically. So here's our line. We know that we can put that in slope-intercept form, y equals mx plus b, where I need to know the slope and the y-intercept. All right, well, the y-intercept we can see right here is back at 0. So that's going to be a plus 0. We know the slope, if we use slope triangle, is going up and over 2, up and over 2, up and over 2. So our slope is up 1 and over 2. So it's 1 half x. We know that we don't need the plus 0. So to correctly write this equation would be y equals 1 half x. And I see that right there. So remember, that's the whole purpose of creating a graph, and in this case on a scatter plot to make the line of best fit is to write an equation for it. So we can do it mathematically. 16, Sangeeta drew a graph of her data and the line of best fit as a visual for her science project. What is the equation of the line? Well, the first thing I notice is that I have a negative correlation up and to the left. So that means it's going to have to be a negative slope. So let's look at which ones don't match that. Here's a negative slope. B has a negative slope. C does not. That's a positive 1 half. And D does not. That's a positive 2. So my only possible answers are A and B. All right, I do know that it crosses the y-axis at positive 2. So which one of these has positive 2 for my y-intercept? Right there. This has positive 1. So I was able to use my information from graphing linear equations, even though we're talking about a scatter plot, because we know in the end, a scatter plot needs a line of best fit, which is just a linear function. That's all it is. So, letter A. Number 17. The graph shows what a household spent on natural gas each day over the last 2 months. If the pattern continues, about how much will a household spend on natural gas during the coming month? So we know a month is 30 days. So we have our days down here, our dollars here. So I'm really talking about this section of the graph right there. That's going to be our 30 days, from 60 days to 100 days, or 90 days. So we're going to use a line of best fit to see the trend. So we're going to start up somewhere up here, okay? And we're going to try to get some below, some above. So we're looking somewhere about like that. Okay, that cuts it about in half. So here at the beginning of the month, we're spending about $2.50 per day. Here at the end, we're spending about $1.50. So what we're going to do is we want to find the average between those amounts and then multiply by 30, because then each day would average out. So if we take $2.50 and add $1.50, we get $4. $4 divided by 2 means we spent about $2 per day. There were 30 days, so 2 times 30 is about $60 for that whole month, so letter B. So that was a little different. We had to use the graph in a different way, and plus we had to use one of the measures of central tendency, average or mean, to do the other one. 18. Daniel is processing a large document on paper. The scatter plot shows how many pages produced each. Number 18. Daniel is processing a large document on paper. This scatter plot shows how many pages he produced each hour. Okay, so we have number of pages and number of hours. So it's taking a lot of hours, and the number of pages, maybe they're really intense, or maybe these are in the hundreds of pages. I'm not sure. Using this information, what is the best prediction of the number of pages Daniel can produce in 10 hours? So it's just like the last problem. Let's find our trend using a line of best fit. So we started out at 0. So we want some below, some above. So it's going to be something about like that. If 3 below. We basically have 4 above. We have 1 on the line. We need to get out to about 10. All right, so now let's match this up. We go up, and we go over. And where would that meet? Right there. That would be the number of pages he can produce in 10 hours. So that's letter C. Pretty handy, that line of best fit. Number 19. 50 teens were surveyed and asked if they skateboard and if they snowboard. The table shows the results of the survey. So this is called a frequency chart. How much something happens versus how much something happens to something else. Of the students who skateboard, what percent also snowboard? Well, first we know that percent basically is like a fraction. It's part over total, which then would equal our percent over 100. So it's a special fraction out of 100. So we can even make a little proportion to find that out. Part over total equals percent over 100. So one of the ways to make a frequency chart a little easier is to get the totals. We know there's 50 teens surveyed. So first of all, let's go right here and go skateboarding. So skateboarding, I have 20 who snowboard and 15 who don't. So there's 35 total kids who skateboard. Okay, how many don't skateboard? 10 and 5. You'll notice 35 and 15 makes my 50 total. I need that to happen. Now let's look how many who snowboard. So I had 20 and 10, 30 who snowboard, and 15 and 5, 20 who don't. Again, you'll notice that's our 50 that we surveyed. So it's easier to get those totals first. Now, of the students who skateboard, you really have to pay attention to the words they're using. So we're on this line right here. Of the students who skateboard, what percent also snowboard? So I have 20 who skateboard and who snowboard out of 35 altogether. Because I'm not talking about 50, they only want to know of the students who skateboard. So I'm concentrating on this line right here. And then they said what percent also snowboard. So here, skateboard and snowboard is our 20 who do both out of the 35 altogether. And so that would be right here, 20 out of 35. If we were to actually do a percent, it would look like this. 20 out of 35, that's my part over total, equals my percent out of 100. If I want to solve this, I'd multiply here, so that'd be 2,000, and I would divide by 35 to get this number. So that in the end would be about 175 and about 7. So that's our 57% in case they didn't give it to us. So the answer is D. 100 students in school sports were surveyed and asked if they are on the football team and if they are on the wrestling team. So here we're doing football and wrestling. The table shows the results of the survey. Of the students who are on the wrestling team, what percent are also on the football team? Well, let's go ahead and figure out our totals this time. So here's how many people play football. 15 and 45, so that's 60. Here's how many people don't play football. 10 and 30, that's 40. Here's your 60 and 40, that's your 100 student surveyed. So now let's see how many wrestle. So I got 15 and 10. I have 25 people who wrestle. I have 45 and 30 who don't wrestle. There's your 25 and 75. There's your 100 people together there. Now, of the students who are on the wrestling team, so I'm talking about this column right here. Of the students who are wrestling, what percent are also on the football team? So that's these guys right here. So I have 15 who wrestle and play football out of the 25 total who wrestle. So 15 out of 25 equals what percent out of 100? Well, they're actually giving it to us. 15 out of 25 right here would be 60%. So it makes it easier if I deal with finding these totals first, and then I got to use the word to determine where in the graph I look for my numbers. Finally, the last one. Though the New York Yankees did not make it to the World Series in 2012, they held the best league record in the American League. So I have home and away, then I have wins and losses. Of the away games, what percent did they win? So let's figure out first what our totals are. So at home, they played 51 and 30. They played 81 games. Okay, of the games away, They had 44 and 37, so they played 81 again away there. That totals 162 total games altogether. That's how many games professional baseball players play. So now, of the games they won 51 and 44, so that's a total of 95 games. The other games they played, they lost 30 and 37, so that's 67. When I add those up, again, that's 162 because they played 162 games. So there's our totals. Now, of the away games, so we're talking about this set of data right here, only this set. What percent did the Yankees win? So I had 44 games that they won out of all the away games, which was 81. So 44 out of 81. And that right there, okay, shows me 44 games, about 54%, 44 games, about 46%. So 44 out of 81, let's do our percent because both of these are the same. So we multiply here, 4,400 divided by the 81. And I'll use my calculator. 44 divided by 81. Okay, so that's about, move the decimal over 2 places, about 54%. So we know it's a set. So now, I could have done the shortcut too. 54% is above 50% or halfway. 46 is below. Well, I know 44 times 2 is 88. That makes this fraction more than half. So it had to be the 54%. All right, hopefully this will help you for the quiz tomorrow.